Hello everyone, Mr. Schultz here for Integrated Math 1, and we are discussing Notes 10.3, dealing with line segments. Make sure you put your first and last name at the top, as well as your period number, as we discuss line segments. Part 1 of 2. Write that in, please. Now, a line segment is a piece or part of a line that has two endpoints. So that looks like the following. I'm going to use my tool to create my line, and then I'm going to draw here's my line, but that's not my line segment. My line segment is going to be what's in between. So if I was going to type it out, I'd probably want to say, hey, this is line segment AB. I know it's a line segment because it doesn't have the little arrow pointing both directions. All right, guys, let's go on. Now, another vocabulary word we're going to learn about is about the betweenness of the points. So this is like the segment addition postulate. So what is this? Well, basically, if we have a line and we know that, hey, look, we have A and we have B and we have C. B is in between C, A and C. We know that. We know that B is in between. Well, we should understand that if we have AB plus BC, that should equal the total, AC. And that's the betweenness of the points. Or I like to just say, hey, it's the segment addition postulate going on. Make sure you write number 1 in. We're doing an easy one to start off with. So find the measure of each line segment. Well, PR, I want to know the total. Well, I know this part is 1.4 and this part is 2.5. Well, I just have to add them. So 1.4 times plus 2.5 would be 3.9. However, it's not 3.9, it's 3.9 feet. So I want to see some work. So what I'm going to do is I'm going to add, and then I'm going to figure out what it's equal to. So if I have 4.9 plus 5.2, well, I could say that's 5. I'm going to minus 0.1. That's 10.2. Now it's 10.1 centimeters. All right, go ahead and try these out, and I'll walk around and check your work. Going on in 3, 2, 1. All right, example 2. Find the measurements by subtracting now. So we're going to get the total. Oh, it looks like number 5 is not an example of that. So why don't we figure that out first? So this is, oh, it is. No, it's not. So let's do it. So if we were to add these together, that would equal 1 point and then 10 centimeters. All right, now we're past that. So we have 6 and we have 7 right here we're going to do. So I know the total. So I know that SV is equal to, well, SV plus VT is equal to ST. So this is, we're basically saying, hey, here's our segment addition postulate right here. Well, I don't know what this is, so I can call this X. Now I'm going to add 2.6 inches. And I know that ST is equal to 4.1 inches. Well, what do I need to do? I need to subtract by 2.6 inches on both sides. When I do that, 4 minus 2 is 2. 2.1 minus 0.6 would be 1.5 inches. So that's equal to X, or that's equal to SV. Let's do one more and set it up for you. So for number 7, it's asking, hey, what's hj? So I know with the segment addition postulate, I know that hj plus jk will equal hk. And I know that each of these is line segments. Don't know hj, so let's call it h. So if we wanted to, we could probably say, hey, let hj equal x. So we don't have to keep saying hj, hj, hj. We're just going to say x. Plus jk is 3.1 feet is equal to hk, 12.2 feet. Now how do we solve for x? Well, it's adding 3.1, so we're going to subtract by 3.1. But technically, we're not subtracting by 3.1. We are subtracting by 3.1 feet. And so we get x is equal to 9.1 feet. But it's not x. Remember, we changed it because we wanted to keep it a little simple. So hj, line segment hj, is equal to 9.1 feet. All right. Now let's hold up for a second. Go ahead and try number 8 in 3, 2, 1. All right, so let's go on. So we have this final part right here, and then you're going to keep answering the rest of these, okay? So write and solve equations to find measurements. So the whole point of this is, hey, look, find the value of the variable and yz if y is between x and z. So every single one of these should look like x, z, y. I don't care where they are, but these are the points, x, y, and z. Maybe y is closer to x, maybe y is closer to z. It doesn't matter. But what we got to do is we have to draw it out. Draw a diagram and then solve it. So, hey, it's saying xy is 11. I'm going to label this xy. And then yz is 4c. So I'm going to write 4c. And I'm going to write z right here. And it says xz is 48 or 83. So I know that 11 plus 4c is equal to 83. Well, now I just have to solve for c. So what I'm going to do is I'm going to subtract by 11 on both sides. And I get 72 is equal to 4c. The opposite of times 4 would be divide by 4 on both sides. Now 72 divided by 4, 80 divided by 4 would be 20, 19, 18. So this would be 18 is equal to c. Well, that's our variable, but it's asking, hey, what is yz? Well, what is 4 times 18? 72. So we put yz is equal to 72. Let's go on. Let's try number 10. So it says xy, so let's draw it out. Let's write x, let's write y, and let's write z. So I know the total is going to be 175. So 175 for the total. I know xy is 6b. I know yz is 8b. Oh no. So I know for a fact that 6b plus 8b has to equal 175. Well, just add them together. 6b plus 8b is 15b. So 15b is equal to 175. All right, well, now we have to figure out what's b equal to. Well, the opposite of times 15 would be divide by 15. And I would just take my handy-dandy calculator, open it up, and get the result. Now, I hope somebody caught that, because I didn't until I picked up my calculator, and I was like, all right, 6b plus 8b is, wait a second, that's not right. 6 plus 8 is 14. So fix that up. So 14. Yeah. So we're going to divide by 14 on both sides. So when we divide by 14, we get that b is equal to, I think it was 12.5. Let's see. Yeah, 12.5. Well, we need to figure out, hey, what's xy equal to then? Xy should equal 6 times 12.5. So I'm going to write 12.5 times 6. Times 6. 12.5 times 6. I get 75. Now I'm going to write yz. Yz is 8 times 12.5. So I write 8 times 12.5. And I get 100. Now, technically, I didn't need to multiply by 100, or to multiply 8 to that. I could have just subtracted 175 by 75 and gotten 100, using the subtraction property right there. All right, guys. For your homework, I want you to finish up with 11, 12, 13, and 14. We're now 11 minutes and 30 seconds in, so I hope you guys have a wonderful day, and we will continue this tomorrow. Bye, everybody.